hopelessly utopian.
By the 1850s, Europe and America were crisscrossed with land-based telegraph wires. But the dream of instant global communication was frustratingly out of reach. This was because there was still no cable capable of carrying messages between two of the greatest powers on Earth, Britain and America. Many experts were convinced that a working Atlantic cable was impossible. But those who disagreed knew that if they could solve this problem, it could make them serious money. And in the 1850s, American businessmen and British engineers joined forces to prove this could be done. Attempt after attempt ended in disaster. The heavy cables kept snapping in heavy seas and storms. Finally, on the 29th of July, 1858, two parts of a cable were spliced together in mid-Atlantic. You see, a single cable was simply too big to have been carried by one ship. Then one end was taken to Newfoundland and the other end to Southwest Ireland. 6 days later, the first direct link between the two most powerful nations in the world was in place. The project was hailed a huge success, and a formal message of congratulations was sent from Queen Victoria to President Buchanan. But before the celebrations were over, things started to go very wrong. This is Chief Engineer Bright's original notebook. You can see here Queen Victoria's original message. Now, it's only 98 words long, but it took 16 hours to transmit. The telegraph operators on the other side found it very hard to decipher the message. The electrical signals that they were receiving were blurred and distorted, and they kept asking for words to be repeated over and over again. So you can see here, repeat after sending, waiting to receive, no signals. Clearly, transmitting across the Atlantic wasn't going to be as straightforward as people had hoped. Over the next few days, several hundred messages were exchanged. But those arriving in Newfoundland became almost impossible to decipher. Just a jumbled mess of dots and dashes. There was a serious problem with the cable, and it was getting worse. Well, the 1858 cable was never fully repaired, and the end finally came when British engineer Wildman Whitehouse mistakenly believed that by increasing the signal voltage, he could force the messages through to Newfoundland. The cable simply stopped working altogether. At the time, increasing the voltage by using more powerful batteries made sense. Most experts believed electric current flowed through a cable like a fluid in a pipe. Increasing the voltage was the equivalent of increasing the pressure in the system, forcing the current through to the other end. But the telegraph was actually carrying pulses or ripples of current along the cable, not a continuous stream. And over long distances, these pulses were becoming distorted, making it difficult to tell what was a short dot and which was a longer dash. By studying the effectiveness of underwater cabling, scientists were beginning to understand that electric current didn't always flow like water, but was also creating invisible electromagnetic waves or ripples. And it's this breakthrough that would lead to a new branch of research into the electromagnetic spectrum and solve the problems of the Atlantic telegraph. In effect, the transatlantic cable was a giant, ambitious, hugely expensive experiment. The failure of science to keep pace with technology had been exposed, and a new, more theoretical, and for me, much more exciting approach to understanding electricity began to unfold. Armed with this new understanding of how electric pulses actually moved along the cable, improvements were made to its composition, design, and how it was laid. It would take another 8 years of scientists and engineers working together before a working cable was finally put in place. And on Friday, the 27th of July, 1866, a message was sent from Ireland to Newfoundland, clear and crisp. A treaty of peace has been signed between Austria and Prussia. At last, the dream of instant transatlantic communication had become a reality.
The success of the 1866 cable makes the world a smaller place, yet again. The change from a world where it took days or weeks or months for information to travel to a world in which information took seconds or minutes to travel is far more profound, I think, than anything that's taken place during my lifetime.
The invention of the telegraph changed ordinary people's lives. But it would be the breakthroughs in how we used continuously flowing electric current that would have an even greater impact. Because inventors were developing a new way of using electricity. To make something every person in the world would want. Electric light. Until the 19th century, we only knew of one way to make our own light: burn things. And by the middle of the 19th century, we'd perfected a very effective way of lighting our homes, using gas. A typical British home in the 1860s would have been lit like this. Highly flammable gas would have been pumped directly into people's houses through a network of pipes. But these gas lamps were too dull for large outdoor areas. So railway stations and streets began to be lit from a more powerful source: electric arc lights. The first arc lights were demonstrated by Michael Faraday's mentor, Sir Humphrey Davy, at the Royal Institution as early as 1808, and they worked by passing a continuous spark of electricity across 2 carbon rods. But their intense white glow was just too bright for people's homes. For an electric light to compete with gas, it would need to be subdivided into many smaller, less powerful and more gentle lamps. Whoever succeeded